Good morning, everyone. Good evening. I'm Krishna Batchu. I have 20 years of experience in IT. So most of my experience belongs to data migrations and data handling. And I different have plenty of expertise in different areas like financial, automobile, energy, healthcare, different platforms I work on it. And I have gained a lot of good experience on data migrations and data handling projects like intelligence data and very large quantity of data I used to handle. And I work with the data governance and it supports and controls and everything. I worked on it. Like ETL tools, I worked on data stage, Informatica, SSIS, Airline. These are the tools which they are developed and they have to be used to use. And I used those. I do have good knowledge on those tools. And what are the data I worked on those tools and as per the business requirements. So I handle a lot of big teams. Like I used to manage the team around 12 people on onshore and 14 people offshore. We have onshore offshore model. And so most of the area I used to work on data handling side, ETL projects, most of things, and that too in migration and banking projects like JP Morgan and US Bank. Those banking side I worked on it. Most of these migration projects like MSP to ALS conversions and those areas. And coming back to investment sides, I work with currently working with Validity Investments, where it's also a cloud-based creation project, which I'm handling right now. So it's dealing with all 401k plans and those stuff. Okay. And in my career, I used different RBM databases like SQL, Teradata, DB2, and cloud-bases databases like Databricks, Snowflakes, and Azure SQL. So these are areas I work on different tools. I work on it, and most of the tools I use to upgrade myself with new technologies and to furnish the new requirement to the projects. And besides that is automation side, I use the PySpark to get this good quality of data by using the PySpark automation tools. And beside the current project, I'm using Selenium and Jexy. So with us too, also we are doing automation where we can do the regression. There are a lot of validations out there. So many checks out there. So on capturing screenshots and validating those logs and everything is done with Jexy automation tool, means automation script. Yeah, and beside that, I work on data. As I mentioned, I work on a lot of platforms on cloud outside. So here I'm going to give the presentation on building self-service and data platform and engineering scalable infrastructure for developers, companies, and other stuff. And coming to the outline of this project is the evolution of platform engineering has fundamentally transformed how organization approaches data infrastructure. Yeah. Slope step how the infrastructure is developing in that in terms of data approaches. So day by day there are new challenges we have to face, and we need to incorporate those new challenges, and we need to come up with some solutions. So to do that, we have good infrastructures on that. And the traditional ETL operations are being reimagined and self-service platforms that empower developers while maintaining the enterprise data reliability and governance. Yeah. At the same time, we need to maintain the traditional ETL operations as well. Being we need to take as a foundation of those, and we need to we need to build a new infrastructure and new ideologies, and we need to transform from the traditional ETL, new ETL, cloud-based or self-service data platforms. Yeah. This is the slide tells about the platform engineering implementers and like product-oriented thinking and developer integration and balancing complexity. The first point is product orientation training. The platform engineering represents a shift from the traditional infrastructure management to the product oriented thinking about internal capabilities. And the second one, developer integration. The most effective data platform feels natural to application and developers, and integrating with familiar CI/CD and process and established patterns like continuous integration and continuous deployment. The process will be there whenever the development is done with the code deployment and code build, they'll push this code into the CI/CD pipelines where it will take auto to go for the push and pull request, and where then the code will deploy into the code, and then seamlessly the process will be developed. Coming to the other point is balancing complexity. And this modern platform must be sophisticated enough to enterprise scale processing while remaining simple enough to general purpose developers. And see, it's modern day IO platforms is handling it day by day, the huge data is coming out. So like more transactions, more legacy data. That the tool that's whatever the selfless servers or the infrastructure should be sophisticated enough to handle those situations. Processing while remaining is simple enough to general purpose of development. This transformation is from solid data engineering to platform driven approaches reflects broader industry trends towards DevOps integration and service capabilities, eliminating traditional handoff between teams. So by doing once we do the automation of data moving or like the CSCD and those stuff. So as of now, we are depending in each team, like hand-upping between the teams. Once like SDLC. Once CLC in the process, once one step is done, we go to the second step. So parallelly also people will work. But going forward, by using this transformation to the latest technologies or data handling things, so those kind of dependencies we are calling to eliminate actually in between the teams dependencies. So the architectural foundations for scalable ETL. So what would be the architectural foundations for extract transformation loading? Okay. Building effective self-service data platform requires an architectural platform that accommodate both current requirements and feature growth. The foundation typically centers on below points. So first thing is that building effective self-service data platform means it should handle the current requirement as well as the previous requirements. So migrating the legacy data or handling the current transactions, it should good enough to handle the previous feature requirement as well. The foundation typically centers on this is architecture that decompose the data processor into discrete decomposed components and containers orchestration platform like providing the runtime foundation and carefully selected data processing engines like Apache, Airflow, these control schedulers and security. And make sure that the usage of data and security point of view, make sure that we are secured at the security level. Also, we need to give a lot of permissions as to provide to the customer and people. The challenge lies in the abstracting Kubernetes complexity from end users while processing access to the its powerful scheduling and resourcing management capabilities. So that's the main challenging what current industry is facing. Abstracting Kubernetes complexity from end user side and while processing, preserving access to the powerful scheduling and resource management capabilities. So if you give the wrong, means the person who is not in the team or is not part of that project, if you give the access to him, the issues will come. At the same time, if you give the access to end user, so there going to be tremendous data leakage will be there. If you don't know, if you go to the wrong hands, there is a issues will be there. And this more comes under the resource management capabilities. And here this slide talks about metadata-driven pipeline architecture. So the pipeline architecture means before going into sliders, I would like to give few insights on this. So pipeline, so how they design the Azure pipelines designed the previous project. So they'll have the data from the different sources and they'll pull it to the large and they'll put it to the landing zone, landing to integration zone, integration to the target. So for each from sources to Azure, they have different one pipeline. And the landing to integrate raw to landing zone, they have one pipeline. And landing to integration to curated, and there is a different pipeline will be there. So these are all integrated by each level. So in integration, landing to integration, they have some ETL transactions will be performed. From integration to curated, there is different level of transactions will be performed. Okay. Coming back to this slide, metadata and data-driven pipeline architecture, the concept of metadata-driven ETL represents foundation fundamentally shifted from the impressive programming models to declarative approaches that separate business logic from the implementation details. So that's what I just mentioned. So traditionally, we use manually, we need to load the data and we need to verify manually, we need to place the data. So then we need to process, separate the business logic from the implementation details. Like business logics from implementation details means like structured metadata and running the interpretations and optimizations. So we need to follow these approaches Like structure metadata means pipelines defined through the structure metadata describing the transformation, data quality requirement, and the operational parameters. So, as mentioned, the data is transformed one and zone to other zone, and the data quality requirements also. So when the data is moving from the raw to integration, the data quality also we need to verify is that the data quality is coming up as per the requirement is coming or not. These kind of checks we need to perform. And operational parameters also, we need to give proper settings like if any real-time data is coming out. So those transactions, how to handle bulk data handling. And the design is you need such a way that if any sudden loads coming, so you need to, a new transformation, new approaches has to be handled on that. And runtime interpretations, platform and the runtime interpretation metadata to generate and execute the appropriate programming workflows. So the runtime interpretation means generate metadata to generate and execute the appropriate processing workflows. So I mentioned that the different pipelines will be there, and we have Airflow DAG where we need to go and trigger it. Manually also we can trigger the pipelines. There's workflows also we need to, once all development is done and QA is done, then make sure that once it's moved to production, is appropriately those workflows running continuously without any issues. After that, opportunity for the parallelism, coaching, and resource optimizations. Here, if multiple workflows are working, this should not any breakage or any war or things like performance issues should not come. And coaching the process every time we have to, if a newcomers coming, we need to make sure that documentation is correctly maintained on each and every step so that if any new changes comes, so we make sure that we take it from the wherever the last step. So that documentation, revisiting we should maintain. And if newcomers are coming, if new people are joining the team, so we need to use the coaching on them. Means we need to mentoring them. And resource optimization. So make sure that while they are using the project, and they should have correct usage, and we should have correct combination of people who is working on the access and those stuff. So this is how we need to do the resource operations and make sure that the correct configuration of the systems and infrastructure we're using. Those also we need to make sure that part of it and transformation implementation of architecture. And this approach makes pipelines more maintainable and less prone to implementation errors, since they focus on business requirements rather than the technical details. So if you maintain all these steps like structural metadata, runtime integrations, optimizations, by doing this, it will more there's no issues with the maintenance and no time errors, no implementation errors, and only focus on the business requirements rather than the technical. Integration with CI/CD and DevOps workflow. So most of the time nowadays, so whatever the development is done, so directly straight away is going for, they're using the CI/CD integration tool and DevOps as part of DevOps. So once the developer extract the data pipeline deployment to the flow, similar patterns, establish application deployment, including version control, automation testing, and staging deployments, roadblock capacity. So by using this continuous integration deployment, we can control this. We can do this like version controlling, and from our previous version to current version and latest version, those we can do the version controlling, automation testing. So nowadays, no manual testing is happening. So most of everywhere, once the code is deployed, we have existing test scenarios and test code source there, where when a code is available, to give the prerequisite test data will be there. Insert the data and run the test suits, we will get automation testing also be done and based on scenarios and less than manual effects and stage deployments when our deployment is done. So they wait for approvals and it will waiting. Staging means waiting for deployments and means one by one, and deployment should happen. And rollback capabilities, if something goes wrong in integration part, there is a capacity of we can roll back those latest versions and we'll keep it as the old version to make sure that business is not impacting. Get-based workflows have become the de facto standard for managing infrastructure and application code. The platforms must extend these patterns to pipeline definition and related to articles. Yeah. And continuous integration pipelines for data processing present unique challenges captured to the traditional application to CAC assets and extending execution timelines. Yeah. cloud native API integration patterns. That's also most one of the data platforms that are using API integration as well. So modern data platforms must seamlessly integrated with the cloud native services while providing consistent abstraction that provide vendor lock-in. Okay. Here we have three topics I would like to cover here. One is Azure Data Factory integration, Databricks integration, API design principles. So first one is the Azure Data Factory integration. Platform step should be simplify data factory pipelines creation while representing access to the advanced features when needed, typically through the template-based approaches. Yeah. And Databricks integration is here requires careful consideration of cluster management, notebook deployment, and job orchestration and automatic provision based carefully considerations. So we should not make sure that the cluster management, what cluster we are using, and job orchestrations we are using, like what notebook we are using. So those kind of cloning while doing the cloning should do the correct cloning and it should also maintain correctly. Coming to API design principles, RESTful interfaces with clear resources, model and consistency error handling, provide the predictive experience, graph, QL implementations can offer more flexible queries cover. Here the API design also, so RESTful interfaces will be there with a clear resource model and consistent error handling. So we used to use the API REST services, right? There most of the times the error-free issues. Since it's a cloud native API integration, to make sure that whatever the configurations nodes we are giving, those requests should be make sure that it's clearly is defined so that to avoid any errors. Yeah. Apache Airflow Acceleration Foundation. This is one of the beginning kind of thing where Airflow is plays as a role nowadays. And Apache Airflow serves as a session backbone for many modern data platforms. As it told, the nowadays it's maintaining and crucial role of Apache Airflow. Due to it's a Python native approach and extensive ecosystem integrations. So Apache Airflow, so we can integrate it with the latest tools or environments. We can do it, and it have Python based. They do. It's a Python based. It's a Python is more emerging. So the Airflow also that's the Python native approach, right? So that's easy to use actually. And the key implementation concerning integration is multi-tenancy and resource isolation and tag generation, the deployment patterns, and custom operator development and monitoring and integration. So the tag generation deployment patterns and their DAGs jobs. So our generations and the deployment patterns, development patterns. So based on that development and how many DAGs are required. So we need to identify it. We need to schedule that pattern also. We need to make sure that in correct order. And monitoring and alerting integration. If one job is triggered, then the monitoring will be there. And if it's any failure, there could be any logs. While running also, we can see the logs and make sure that is there any issues and how this completed and what stage it is. Those we can monitor them as well. Rather than requiring users to write Python DAG definition directly, successfully platforms typically provides high-level abstractions that generate S4 DAGs from metadata definition. So metadata definition itself, there's generated S4 DAGs will be created, and we can use those patterns, and we can start using those in development, and we can schedule it actually. Infrastructure as a core for ETL development. And infrastructure as a code principle that transformation ETL development from manual error-prone process to automated repeated procedures to integrated naturally with the software development workflow, like tag workflows. And here there's three points I would like to discuss here. One is Terraform modules and Helm charts, DevOps flows. The Terraform modules are encapsulated common infrastructure patterns for data processing workloads, enabling teams to deploy the complex multi-service actions through the simple configuration declarations. And by using Helm charts, provide the Kubernetes data approaches to infrastructure as code that align with containers based on the data processing, orchestrators, and through the deployments. And coming to data workflows, infrastructure changes triggered by the commit Git repositories, creating audit trails and enable sophisticated approval workflow through accounts like Argo CD and Flex. And work for data quality. This is the one of the critical rules is the data assurance. Data quality testing represents fundamental requirement for the enterprise data platform. Such traditional testing approaches often prove inadequate for modern data processing workflows. Yes. Comprehensive testing strategies includes testing with authentic data generation and regression testing in container-based environments, schema evaluation testing for backward compatibility, performance regression testing with the baseline comparison. So by using these four levels of testings, make sure that whatever the data is handling and processing as data quality would be perfect and unlike traditional software testing where the mock object can simulate external dependencies, data processing tests are often required representative data sets that capture the complexity and edge cases present in the production data. Yeah. Production data means production data is final data, so it should not any issues and errors in that. So by doing the good quality of checks, can avoid errors in the production data. Monitoring and observability of standards. There are four ways of we are doing the monitoring and distributed tracing and matrix collections and log aggregations, intelligent alerting. By using these four, we are monitoring and observability standards. And here, comprehensive monitoring and observability capabilities are essential for the maintaining reliable data platform operating at enterprise scale, enterprise level. And distributing tracing is critical for understanding complex data processing workflows that span multiple services and processing stages. System like here and Jipkin provides a detailed execution visibility. And going to matrix collections, time series and databases like InfluxDB provider efficient storage and querying capabilities of both technical performance indicators and business-relevant process outcomes. Coming to the log aggregations, tool like Elasticsearch and Splunk handle high volume of data and log output with sophisticated search and analysis capabilities for rapid problem identifications. Coming to intelligent by using the aggregations, by using this research is very quick, we can come to where exactly is happening. And intelligent alerting is sophisticated alerted correlation escalations policies like ML-based anomaly, detecting and identify the subtle issues, either reducing the real-world implementation experience. Practice implementation of self-service data platform across a diversity enterprise environment provides the valuable insights into both the architectural pattern and organizational changes management strategies. So here the industry-specific challenges are important. Financial services like regulatory compliances, data governance, and risk management requirements. And healthcare, coming to healthcare like HIPAA compliance, patient privacy, and Alexis and tracking, fraud detections, real-time processing, core system integrations, and those we need to see it. Airline operational and disaster required, and operational reliances and disaster requiring capabilities, and the developer experience and cognitive load actions. The source of self-service data platform ultimately depends on their ability to reduce the loads for the development teams while providing the powerful data processing capabilities. Like tool design, like well-designated CLI tools for flow establishment, conventions for parameter handling, output formatting, and error reporting with the comprehensive help system and completions. So by using this CLI design tool, we can perform all these ones, like parameter handling, output formatting, error reporting, all these things we can handle it. And web interfaces must provide the relation of complex data processing workflows while enabling sophisticated configurations and monitoring capabilities. Documentation, interactive documentation system that combines explanatory content that executable example provides effective learning experience. Governance and compliance and platform architecture, so data lineage, audit logging, and access control and privacy protection. As I mentioned, so data governance and compliance is very key to the company. Based on that only, If you speak openly, the stock market and all the stuff will be based on this umbrellas only. So there is no data leak or they maintain all standards. So that all the business is doing, all standards should be on the accounting will be there here. And the data lineage automatically capture the data flow information as a pipeline and execute, maintain detailed records of source, transformations, and designation for the compliance reporting. And access controls integrated with the enterprise identity system while providing the fine-grained permissions through AVAC systems for dynamic authorizations. Audit logging captures the comprehensive activity records for all user actions, data access, and configuration changes with sufficient detail for complaint reporting. Privacy protection, like regulatory requirement like GDPR, CCPA through the authorization data discovery, classification, anonymizations, and deletion capabilities. So data governance and compliance are the key for the company. So by using these four things, the architecture of is like data lineage, access control, audit logging, and privacy protections. And the feature actions and conclusion of this task and transformations are here the emerging patterns are serverless computing for more efficient resource utilization, right? And machine learning integration with model elastic management. Yes. And real-time processing and capabilities with the steam processing frameworks and edge computing scenarios spanning cloud and edge environment and AI-powered platform operations for optimization monitoring. And these are all changing patterns and the new technologies and you have to do the data handlings and data transformations from the legacy to the new one. Next to success, yeah. Building the effective self-service data deployment is required is a holistic approach that balance the technical sophistication and the user experience considerations. The most successful implementation treat a platform development as a product development with a clear user persons, interactive improvement cycles, and comprehensive feedback mechanism. And organizations that successfully implement comprehensive data platform that strategies gain significant competitive advantage through the improved developer productivity, faster time to market, and more reliable operations. These are all key to success directions, actually. Yeah. Thank you. And thank you for giving the opportunity to present myself and my work and giving thoughts on it. And I'm happy to share my experience and presentation here. Thank you very much.